This is your overview of skills and expectations for your waves unit. This is going to take about 4 weeks and pretty much run us right up to spring break. First week, we're going to look at Introduction to Waves. What is a wave? You need to know the parts, including frequency, period, wavelength, velocity, phase, and amplitude. We need to be able to identify a wave as either longitudinal or transverse, or mechanical or electromagnetic. And your skills basically for this week, you got to be able to draw and label frequency, period, etc., on a wave. You have to be able to classify it, and then, of course, math behind it, turning frequency into period, finding velocity from period and wavelength, that sort of stuff like that. Our second week, we're going to focus on what waves do. We're looking at things like refraction, reflection, diffraction, and dispersion. And we'll throw index of refraction in there as well because we need that for studying refraction. Your skills for this week, identifying behavior. If I give you a picture, what is this talking about? Drawing ray diagrams. This is a big skill that we're going to hit week 2 and pretty much continue through the rest of the unit. And then involves drawing with a protractor and a ruler how the light would behave when it does various things. And of course, we need math to back that up as well. Week 3, we're looking at more wave behavior, less mathy ones, but interference, Doppler effect. And then we're going to start talking about optics. How do we put various things together to make light do what we want it to do? And then finally, week 4, we're going to look at more optics again, mirrors, lenses, prisms. You're going to have to create a telescope as part of this in lab. And your skills basically here are drawing ray diagrams for optics, how is the light going to work when it passes through a lens, through a mirror, through a prism, etc., and a little bit of math to back that up as well. This unit's pretty light on the reference tables. There's not a lot of looking up stuff. We do have the speed of light in the vacuum and speed of sound in air on the front page of your reference tables. We'll need to use those for week 1 and then again later on through the math. We have the absolute indices of refraction. This is only a partial list, the full ones on your reference tables. We'll do that when we study refraction, and this basically tells us how fast light travels in a given material. We had the electromagnetic spectrum. This is going to help us a lot with light. Pretty much we use it for classifying. If you have a frequency of 10 to the 17th, what type of light are you? Regents likes to focus in on the visible light and talk about what color light would be and stuff like that, but it's pretty much just for reference purposes. Although it does give you a pretty handy way of comparing wavelength to frequency as well. And then, of course, the math. Not that many equations, and most of these are pretty straightforward. Velocity of a wave, period, and frequency. And then the last 4 are all about wave behavior. The theta I equals theta R is for reflection. And then the 3 lower ones are for refraction, when light goes from one material into another. All right, and that's about it. You guys have, I think there's 5 videos on this. We'll pretty much 1 or 2 for each topic. But most of the stuff's going to be done in lab and playing around with slinkies. Okay, so that's pretty much your overview and expectations. If you have questions or concerns, shoot me an email, ask me in class, or post it up on Google+. And we'll see you in class.